Thank you so much. And first of all, we will start. Thank you for organizing this. You know, it's a lot of work, and I appreciate it. So, before we start, from yesterday I've noticed that I need to explain what the Max Planck Society is. So many people don't know this, probably only people working in academia or maybe some people in Germany. To be honest, I also didn't know it before I started working there. So the Max Planck Society consists of 86 institutes. So it's not one institute, it's 86 institutes, and we have a couple of data centers and service providers, and all together is the Max Planck Society. We have, I think, in total roughly 16,000, 17,000 researchers. So it makes us one of the largest entities worldwide. Publishing-wise, I think we're also in the top 5, and we're proud to have, I think, now 38 Nobel Prizes. So it's quite a big organization. About this presentation today. So in good scientific practice, I took the presentation of a colleague of mine, made some minor changes, slapped my name on it, and pretend now it's mine. So what we do is we run Bloxburg. So 2017, ages ago, feels to me like ages ago at least, we approached our scientists, and usually we try to figure out what they need. So part of my job is we check out new technologies, like AI these days, or blockchain in the past, we do drone projects and so on. And then we do like small projects, we try to figure out, can we make out of these technologies something that our scientists need? Obviously, we ask them first, is there a use case to it? And in 2017, a lot of scientists came up and said, you know, I would like to share my data a little bit earlier than I used to, and I cannot, because I'm always afraid that someone comes and just scoops my data and publishes it first, and then I'm sitting there talking to my professor, to my instructor, and they tell me, yo, you have to find something different. So we figured, okay, is there a way to actually protect this? We said, yeah, probably we can do this in our own data center, but it doesn't make much sense, because any system admin can just change the timestamp, for example. So at the time we figured maybe a blockchain is actually a good solution. So yeah, just going back one more slide. So if people are wondering how our organization is doing science, so this is like bleeding edge science. People print out posters and then they meet and talk about this stuff. So this happened like 5 years ago. It's a little bit more digitalized now, thankfully. But that's how we actually get input on the services we want to build. So this is what I mentioned, the challenges. I think you heard this plenty of times now in the last couple of days, the pressure to publish fast, publish or perish, what people say. And people are just really, they do not want to have their stuff stolen. And to give this also a bit pragmatism, there's also a couple cases. If you check out CRISPR, for example, it's still, I think, in court, and there's still a dispute who was the first one to do this stuff. If you would have had some evidence on a blockchain, I think that's still, that would have been easier to solve. Anyhow, what I mentioned is we said we cannot have it in the centralized system, so that's why we ended up with a decentralized system. So, I mean, thankfully I don't have to explain anymore what a blockchain is. A couple of years ago that was a bit different, so this one is clear to you. Going back to when we then decided what we want to build. So also, most people yesterday asked me, why do you build your own blockchain? Again, the reference point is important. We started this 2017, the world looked a bit different. And also, if 2017, if, for example, we went to the president of the Max Planck Society and told him, I want to buy some ether. And I said, yeah, here's the door, never come back again. So at the time it was still, you know, drug dealing, buying illegal stuff, and all this kind of stuff. It got a bit better now these days, I think. It's still a little bit hesitancy. But we pretty early came to the conclusion we cannot use any of the typical public blockchains, like at the time Ethereum, Bitcoin. Also, Ethereum was still super wasteful at the time. It's just a no-go. The private ones are, I don't know, I mean, we also thought private ones doesn't make much sense. So we came to the conclusion we need something that is a mix of both, so public permission. So also Ripple is also probably not the fitting one. So in the end, we came to the conclusion, I mean, it's not a surprise now, we build our own blockchain. So now we want to fulfill some stereotypes. We are sitting in Munich, MPAG is also, the Max Planck Society is also headquartered in Munich. And now we also have a reputation that we apparently have a lot of money, which is not the case. We also don't have so much money like VCs and everything these days. But we own a castle. So we decided we just ask a couple of friendly institutions, and we bring everyone to our castle. That's the one you see on the picture. It's close to Tegernsee, so you are right above Tegernsee. Look over the Tegernsee, it's pretty nice. And then we brought everyone in a room and said, you know, until you sign this, you're not going to leave the room. So this is actually basically how we tell a story now. It's quite a little bit different. But as you can see, eventually everyone hold their hands and waved their hands and said, you know, we agree to this. And again, in stereotypical fashion, my colleagues, they went in dindles and yeah, typical Bavarian style. Anyhow, that's how we started blockchain in 2019, and then pretty early then we just took the code base from Ethereum and just built it with proof of authority. So brings me to the next slide. These days we are at least we think, the largest proof of authority network. So we have, over the time we had like 20 million transactions, we have over 55 members. I have to say to this, we don't do any cold approach or anything for our blockchain. It's just people approach us and say, you know, I work for university, this is a nice project, I want to join. So that's how we do it currently, and then we are over 55. We also have over 30 applications that have integration of some sense. How does it look like? That's a typical block explorer that you know from other blockchains as well. What's pretty nice here is you can actually see who's mining my transaction. So our network is unique in a sense. I come back now to this public permission. It's permissioned in the sense that each of our institutions that joined our little association, they run one node, and we only allow research institutions. So this saves us all this overhead of competing resources like proof of work. We also do not need proof of stake. We just do a round robin of all the nodes that are whitelisted and are online. This also means that no one else can mine this, so that is the permission part. But you would also see who's actually mining your block. So in this case, you have like Fraunhofer, for example, Simon Business School, or University of Geneva, and the Karlsruhe Institute of Technology. So that's quite interesting. And it gives also, there's a couple people that actually want to know who's running the network, especially, let's say, older people. They still don't trust this whole decentralized network. They say, you know, in the past it was, you know, someone in China is mining my stuff and burning coal. These days people say if you look at Ethereum, then it's all running in Amazon cloud in the West and so on. So there's still, ironically, we put a little bit trust into a trustless network, if that makes sense. So this is a slide where we put all the logos. It's also very important, and essentially repeats a little bit what I just said. You know, one node per institution. What we also did is like every project we start this really naively and just see where it goes. So there was 12 institutions at the beginning. Sometimes it was just a private person joining and representing the institution. So eventually we said, you know, people were afraid about liability because personal liability about all this stuff. So we said, okay, let's put this into a legal body, and we came to the conclusion we do like a German Verein, non-profit association, and that's what we did last year. So we managed actually to have almost all of the institutions now join, even the Max Planck Society. The president actually signed, and yes, I want to be part of an association that supports and runs a blockchain. If someone would have said this to me in 2017, I would have laughed at it, but it actually happened. So this is not what we try to solve. I think it's not necessarily a technical problem, but it's a more organizational problem, and also a little bit educational problem. So we are happy that this actually changed over time, and also we do not have to, like I said, explain anymore what a blockchain is. Good. A little bit about our integrations. So what we also tried, we tried a lot of things the last 5 years. We failed with a lot of things. We also tried to revolutionize publishing, for example. That's not going to happen. We are not going to do this, and we even have the colleagues who argue with all the big publishers about open science. So actually, our colleagues are the driving force that people in Germany can read the papers, but even we say that's not going to happen. So we still did a couple of implementations in the end, which worked out. I mean, there's the typical stuff like the core applications. We need to see which kind of nodes are online, the Block Explorer I just showed. We also have a data certification, which I'm going to show you. then just what we focused on is really integrations. So I think for the typical user, they don't want to interact too much with wallets and so on. So let's keep it simple. We have, even though we have a couple IT affine people, they use something like Wolfram Mathematica, for example, a notebook where you can visualize a lot of stuff, super complex models, and they obviously don't know how to interact this. So there's a full integration. They can just take whatever they do and then just leave a digital fingerprint. We also do a little bit more fancy time stamping. That's also, it doesn't sound very sexy, but time stamping is really something that helps our scientists. So directly integrated into an eLab notebook, for example. Or we have the last one in the middle is Eternity Cloud. That's pretty interesting. They try to do like decentralized computing. So they try to tap into resources that are used and orchestrate everything. Try to make it reproducible because they store everything like the workflow on the blockchain and try to execute it. So also from reproducibility, that's quite interesting. We also have a couple members that implement solutions. If you want to check this out on our homepage, blockspec.org, there's a lot of stuff to this. What we did ourselves for our scientists is we provide an API where people just can program against, develop against, or they just can use an online service to certify their files, and we also integrated this to one of our services. Similarly, I think yesterday there was also a similar idea, so we are not the first ones and surely not the last ones with this idea. So, like I said, back to this initial use case that people said, you know, I want to secure my data. That's why we built this service. It's fairly simple. You just go to a homepage, you drop your file, and then you can add some metadata and then receive a PDF. A PDF is still something, you know, people maybe even can print it. We still like our paper here in Germany, even for try to be a little bit digital. But they just receive a PDF which has a payload, and you can verify it at a later stage, but it also has a couple of information. We're currently redesigning this, so this is a little bit, I think we did this like 3 years ago, so it might look a bit outdated. We'll have a new version soon. Right, Aditya? Good. What we also did is, like I said, we focus on integration. So it should be usable for people. It's not like, what didn't work for us is like blockchain in your face. People just, they're interested in the benefit of a blockchain. Also, for example, libraries and so on. So really people would think they don't care much about the technology, but they're really interested about the benefits. So what we did is we have a sync and share solution. Think of it as Dropbox, Google Drive. Dropbox, Google Drive. We just base it on C file, and it has full versioning. So we thought, okay, this is a good idea that we combine this blockchain certification, what we call it, and also the full versioning. Because think about this, our scientists do basic research. So the research really. Last time I talked to someone and asked the professor, what are you doing actually? And she said, yeah, I'm trying to figure out what conscience is. So there's no evidence that this is going to be commercially used. But then every once in a while something pops up, and then CRISPR happens, for example. So they don't really know what comes out of it. That might happen like 10, 15 years later. So this will be good for them to still leave this digital fingerprint. And we tell them we store your data for at least 10 years, probably even longer. And we have this full versioning. Just press a button if you have something super important. Then we also put a hash on the blockchain. So if it comes really to this dispute at a later stage, we just can go back, we can give you the file, you can see, okay, this is exactly the hash, and we at least can provide information that this file existed. If it still then belonged to this researcher or not, that's a different story, but it helps surely. So what we did is people just can press a button. They can also add some metadata if they like. Here's a couple of screenshots to it. So you see, it's just basically, that's the typical sync and share solutions. They all look like similar. We just added this button, people press the button, something happens in the background, we store the data on a different page, and they can just do whatever they want. So they're also very lazy, similar to VCs, what we heard. It's really, if you ask for too much data, people just don't use it. This is a little bit more enhanced, so they can add also some metadata, also pretty simple. We will not expose this metadata, but rather take this metadata, attach it, and then hash it again, because we also have institutes working on patents, so that's also important. So this is how it looks like when you try to verify it. Then a fancy animation happens, tells you a lot of stuff that's happening in the background, so also get some user feedback, and this is basically how we store it. So you can see people can download the file in the top left, and also the certificate. So they just once they press the button, they can just forget about it, and at a later stage, if it's really necessary for them, they come back to this. About Bloxburg itself, so for this integration, we mint an NFT. So far, we have almost 18,000 NFTs, so there's actually people using it. Previous slide, it was also mentioned, we have like a fire and forget also for over 1,000 files, so this one would be batched and would be one certificate in the end. So it could be way more files that have been certified, but at least we see that 18,000 times it was used, which is quite okay, I guess. Now, like I said, a lot of animations. It's not my presentation, but it's still fine. Now with the outlook for the future. So, obviously through our connections, we talk to a lot of publishers, for example, and funnily enough, I'm pretty proud of it. Wiley actually added this now to the guidelines for the scientists when they publish in natural sciences to please secure the data. So they actually wrote it down and say Bloxburg is nice and use a blockchain to make sure your IP is protected. We also met at CERN this year. So this is only a part of from this year with Digital Bauhaus initiative. So totally different architecture. They also say, you know, we have to protect what we're doing. So this whole IP protection, that is something that is really, people are really concerned about. Also certifying, and what we also think is in the future, really provenance is going to be super important because we're on the verge of uprising of AI. Also the publishers are really concerned about being bombarded by AI generated papers, which they're going to be, and they need to know where that actually comes from, all the data. What we also think will be something that pops up is scientific identity. It's a bit similar to digital identity. I mean, everyone probably knows about apes and all this stuff, NFTs. It's a way of individualizing your digital representation, and we think in a science context with like the NFTs, what we also showed what people can mint. We also think this could help to building a profile for individual scientists that you just see. Okay, this is a paper I worked on, this is the data I generated. It doesn't always have to be something that's published. There's a lot of stuff that can be opened up, which can be useful for others, which is currently not being opened up. Probably like 99% is still behind closed doors. So also that's what we meant, research, data, marketplace, all these kind of areas. There's a lot of stuff that's useful and that can happen. And also research funding, I mean, that's evident. Everyone, I think, knows a use case that's been here for today and yesterday. All right, that's it. Thank you for listening. Happy to answer a question.
Round of applause. Rene, maybe I can pose a quick question. You said you had over 80,000 researchers within Max Planck institutions, or overall, your grand institution. How do you see the adoption from those 80,000 researchers to use Bloxburg or to get into the realm of, protecting their IP with this piece of technology that basically your family is providing them?
Yeah, so it's 18, so we are mumbling, but still it's a lot, yeah, okay. 18. So now the sad truth is, usually, so it goes back to the decentralized nature of the Max Planck Society. We're a bit of a weird bunch. So the Max Planck Society has an idea. They find a brilliant scientist. The scientist becomes a director, builds an institute, and then those scientists and director, they can do whatever they want. So it's not even that we have sort of guidelines. People use this kind of software, but we have to work like a startup. We have to convince them. So there's a couple of institutes that actually use this. They see it as a feature where they can protect the data, also data integrity, so different use case if they archive something, for example. But I'm not going to lie, it's always an uphill battle. But it's not unique to blockchain technology. Any service we develop always takes time until it's being adopted. And we also have to admit that we're still very early with all this kind of stuff. And the good thing is, I mentioned this before, I see it's getting way, way better. So 3-4 years ago, we had to go to the institutes and explain blockchain is not just money laundering, buying drugs. There's actually a use case behind it. So everyone these days, I think, knows what a blockchain is. That's good. And they see the benefit. And I think for the user itself, it doesn't matter if there's a blockchain. They just want to see the benefits and use the benefits and have the benefits. We try to integrate it in more and more solutions, and then we also see that people start using it. But they just do not start using it because we say blockchain 3 times. It's a bit different to the past, I think.
Okay, thank you very much. All right, another round of applause for Rene.